Okay, welcome back, you cool cats and kittens. How are you? We're going to be looking at the third day of polar graphing here today and what are called rose curves. And a rose curve is going to happen when you have a polar function in this form, r equals a sine or cosine of n theta. And the key is that n multiple on the inside of the parentheses because as you should know, if it didn't have n, or if n was 1, in other words, if it was just a sine of theta, that's just going to be a circle, or a cosine of theta is just going to be a circle, symmetric with the x-axis or y-axis. When you throw n in, some multiple, that's going to mess with it a bit. So let's just kind of see what happens here. One way, again, you can start by plugging in points, or you can sketch the sinusoidal graph, or the book has, their own way of going about it with doing all these symmetry tests and this and that, but as you probably should know by now, I like to do the sinusoidal sketch. And if you're a person who just wants to plug in points, that's fine too. But just remember, in terms of the points you plug in, the thing that's affected, the major aspect that's affected is the period. So the period, remember, is always 2 pi over b, or over whatever that coefficient is. So in this case, the period is going to be pi. So in other words, your new increment isn't going to be pi over 2, it's going to be pi over 4. So if you're plugging in points on a table, then I would just say use pi over 4 multiples instead of just breaking it up at the quadrantal angles. And that should probably do the job for you. The rest of us, let's just do a little sketch here. But I'm still going to go all the way to 2 pi, which just means I'm going to get through 2 cycles because of that 2. So there's pi over 2. Remember, these are just rough sketches because they get you a lot of points in a hurry. 3 pi over 4, 3 pi over 2, 5 pi over 4, 7 pi over 4. Okay, the amplitude is 5, the midline is 0. On these rose curves, all our midlines are going to be 0, so we're keeping it simple here. This is really a little introductory lesson to these. You'll do more with them next year if you take BC Calc, or in Calc 2 someday. This is a positive sine graph, so we start at 0, 0, right on the midline, and then at the next key point, we're going to be at the crest, 5 units away. And that's going to happen at pi over 4 now, instead of pi over 2. And then pi over 2, we're going to be back to 0, 3 pi over 4, and pi. See, we go through one complete cycle, but now it only takes pi units to do that. And so going pi to 2 pi just repeats that cycle. We get through a second cycle. There we go, crest, midline, trough, back to the midline. Okay, now where are all these points on the polar plane here? Well, 0, 0, same spot. That's right at the origin, right at the pole. Pi over 4, 5. So when r is 5, when theta is pi over 4. So 1, 2, 3, 4, 5, and pi over 4 is going to put you right about there. And now pi over 2, but r is 0 again. So when r is 0, that puts you right here. So let's just take a moment here and examine what just happened between there and there. I went from here, starting at 0, 0, and as we rotated between 0 and pi over 4, my r increased out to a maximum of 5. So as we rotated, my r lengthened and got out to 5, and then after that, as I approached pi over 2, as I continue rotating, my r decreased and got sucked back towards being 0. So what happens is we got this, what's called a little petal. It's a petal on a flower of the rose curve. But you could probably just see that if you plotted all the points. But I kind of like to see the progression there. Then r is negative 5 at 3 pi over 4. So 3 pi over 4 would be right here, and going 5 but backwards because it's negative. 1, 2, 3, 4, 5. putting you right there, or 5 to the left, and then rotate 3 pi over 4 from there. And then back to r being 0 at pi, well, that just puts you right back at the origin. So guess what that does? That just does another complete pedal. 5 pi over 4, r is 5. Well, 5 pi over 4, that's right here. 1, 2, 3, 4, 5. And then back to the pole, back to the origin. So you get that between there, and then you can probably guess where the rest is going to go. But 7 pi over 4, but negative 5. So 5 to the left and 7 pi over 4, or 7 pi over 4, but go 5 units back. 1, 2, 3, 4, 5. And then back to the origin. So if you wanted to follow sort of the cyclical nature, it just went like this. And it would really just repeat over and over again. If you kept sketching sinusoidal graphs, it would just continue tracing around this in that same pattern. And again, if you'd like to see it play out, of course you can type it in Desmos, but if you graph this on your calculator, you can see it. Oh, sketch that. It's so nice right there. And there we go. That's the rose curve. Notice, without that 2, it would have just been a circle on the y-axis. You throw a 2 in there, and now it's a 4-petaled. Having 2 made 4 petals on this flower, and it is still symmetric with the y-axis. So now putting a 3 in there, how many petals do you think that's going to have? Well, let's just find out. You can definitely make a conjecture here, pause it, sketch it, see if you're right. But let's think at least about if you're a person who's plugging in points, or however you're going about this, what is that 3 effect? Our period is going to be 2 pi over 3 now. So our incremental values, our sort of affected quadrantal values are going to be that, but divided by 4. So 2 pi over 3 divided by 4 is going to give you 2 pi over 12, or pi over 6. So it's going to go through a cycle every 2 pi over 3, or in other words, between 0 and 2 pi, it's going to get through 3 cycles worth. So this is, again, just a super rough sketch here. But 2 pi over 3, there's going to be 1 cycle. Another 2 pi over 3 would put you at 4 pi over 3, and another 2 pi over 3 would put you at 6 pi over 3, or 2 pi. Our amplitude is still 5. I figured I'd keep that consistent. And then every 1/4 of that period is an increment of pi over 6. So pi over 6, 2 pi over 6, which is pi over 3, and 3 pi over 6, or pi over 2. 4 pi over 6, 5 pi over 6, 6 pi over 6, or pi, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, which is 3 pi over 2, 10 pi over 6, which is 5 pi over 3, and 11 pi over 6, just before you get to 12 pi over 6, or 2 pi. Ooh, pretty congested here, so trust me, I'm not going to give you any problems where we have, 7 theta or 8, 9. That's when they get really funky on Desmos, but I'm not going to have you sketch those by hand. So this positive sine cycle between 0 and 2 pi over 3, so at pi over 6, we're at the crest. Pi over 3, back to the midline. Pi over 2, back to 2 pi over 3. There's your one complete positive sine cycle, and then that's just going to repeat. So like I said, if you don't use this method to sketch the graph, that is totally fine with me, but I kind of liked it to review these properties. It's a kind of nice way to tie all these things together that we've been talking about all year. So starting again here at 0, 0 means we're starting at the pole, pi over 6, and having an r value of 5. So 5 pi over 6 will put you 1, 2, 3, 4, 5 pi over 6. and then back to r being 0 when theta is pi over 3. So that puts you back at the origin. So that one cycle right there is going to make that one petal. All right, well, now at pi over 2, r is -5. So pi over 2 is right here, but -5 means 5 units behind that, or backwards. It's going to put you down there. That's different than the last one. And then r is 0 again at 2 pi over 3. So we're back to the origin. So what's happened between here and there? This trough is represented by this petal. So what happened? We went from there to there, and we continued sweeping around, and then our r extended out, and then we continued rotating, but r got pulled back in to being 0. And now, continuing along here, 5 pi over 6, r is 5. So 5 pi over 6 is right here. 1, 2, 3, 4, 5. And then right here, back to the origin, back to r being 0. So went like this, sweeping around, and then back to there, and then back to the origin. And now what happens here? 7 pi over 6, -5. So that would be 7 pi over 6 is this line right here, but -5 would be 5 units backwards. So right here in the first quadrant, 1, 2, 3, 4, 5. It actually puts you at that point you already have. And then you'd be going back to the origin. So you see what happened here is it actually started to trace onto itself again. If you kind of go back to the beginning here and just follow the pattern, went like this, went like this, and then just went like this, and then back to 0. And now this, 3 pi over 2, if you want to check, 3 pi over 2, r is 5. Well, that's right here. Puts you right back on here. So now you're just tracing around again. So over and over again, it's just going to do that same pattern. So you've actually completed it by the time you've gotten to this point. So notice 3 theta, you only had 3 petals. 2 theta, we had 4 petals. So there's a little trick here. However, notice it was still symmetric with the y-axis. It's a sine polar function. So little things that can help if you can pick up on them. If the n, that multiple on the inside, the n times theta, if n is even, there will be 2 times n number of petals. That's why we had 4 here. If I had put a 4 theta, there would have been 8 petals. But if n is odd, like in this case, n was 3, and we had 3 petals. So if n is odd, you'll just have n number of petals. So okay, so you've seen two examples, one with an even, one with an odd. That might be good for you. I'm going to make a second video of the back side of the worksheet, but feel free to just give it a try on your own if you like, and check out Desmos, or watch the video if you're still a little confused or just want to see another couple play out. And as always, hit me up with questions if you've got any. Hope you had fun and enjoyed this.